Hello everyone, welcome to the live class. So guys, today we are having a very important session of mathematical physics, and in this we are going to discuss the contour integration. So each and every point which I will discuss in today's session will help you all to make a good command on the topic contour integration, as this is a very important topic of mathematical physics for the CSIR net physics exam as well as for the gate physics exam. Okay, so if you are someone who is preparing for CSIR net or even for gate exam, this session is going to be a very important session for all of you. I hope that after attending these sessions, basically guys, there are different parts for the contour integration topic. Okay, so this is our first class, and don't worry about it because we will start from the beginning in this session. So guys, here initially before starting the discussion about the topic, I will just take a little time and I will let you know about the many important things, like I'm going to provide you the information about the Unacademy Plus subscription and its benefits and everything. Along with that, here many new plus courses which have just like in January starting. These are the courses which are going to start. Clear? So guys, like the capsule course on physics with practice questions. This is like going to start in January. Then complete course on core topics of physics for June 2020. This is a like I would say 3 months course. Okay, and there are all the subjects of your syllabus for CSIR net exam. So in this second course there will be like all the subjects which you will get. Okay, and this is going to help you all to prepare well and to know about all the important topics of all the subjects. All means like mathematical physics, quantum, classical, whatever subjects are there in your syllabus of CSIR net physics exam. Then crash course on physics with previous year questions. Again, this is going to be the important course. So all these are the courses which are going to start in the January starting. If you want to attend the live classes of all these courses guys, like the complete course on physical science, complete course on electronics and thermodynamics, course on advanced level quantum mechanics, complete course on classical and mathematical physics, capsule course on differential equations, crash course on physics with previous year questions, Excel for physical sciences, and also capsule course on physics with practice questions. So you can see there are so many courses, and these courses are by all the top educators we are having on Unacademy Plus for your exam preparation. Now guys, the point is, okay, these are the important courses and going to start in January. So if you don't want to miss any of the live classes, you can take the Unacademy Plus subscription now. And you can see here I have also mentioned all the other important details. Okay, so as per the date when we are discussing it, okay, we are having these like I would say the subscription amounts for different durations. Now you can take the subscription for 1 month, 3 months, 6 months, 12 months, 24 months. Now since your exam is in June, I would suggest you to take the subscription for 6 months because it will be more beneficial, and you can see the amount which you are paying for like total 6 months. If you are going to try to find the amount for 1 month, you will find it's less in comparison to other two. Okay, so that's how you can get more benefits. And whenever you are taking the subscription, use the referral code Anjali Arora. Okay, apply it, write it in the same manner and get the 10% discount in the total subscription amount. Along with this guys, if I'm going to talk about the steps to take the Unacademy Plus subscription, then first of all you need to download the Unacademy learning app. Okay, log into the app, then select your goal. Like if you are preparing for CSIR net physics exam, your goal will be CSIR UGC net. Then click on the 3 lines you will have on the left hand side top corner, then click on plus and then click on get subscription. Okay, and you will just follow the further steps after that, and that's how you can get the Unacademy Plus subscription. These are the courses which are starting in January. Okay, these are the plus courses. Along with these plus courses guys, I'm going to tell you about the special classes. Okay, so mainly there are special classes scheduled in January, so which are having you can see the dates here. 1st January we already had the session 1 at 10 a.m. Okay, so timings are 10 a.m. for all these special classes. You can just check it here Okay, then you are having the session 1 of classical mechanics, then session 2, session 3. So there we are going to discuss many important things or important topics of classical mechanics. Now the thing is, what is the difference in the special classes, in these live classes and the plus courses classes? So guys, in the plus courses you all will be able to know about the things in detail. There will be like more regular study we will do. We are going to discuss each and every important subject, okay, and the topic. So that's how the things will help you. Very good morning, Soumya. Hello, Vijay. Okay, so guys, like this was the information about the Unacademy Plus courses subscription referral code, which you can use and get the 10% discount in the total subscription amount. Here is a schedule for the special classes which will be conducted on Unacademy Plus. You can even attend these special classes. Today also, after this class at 10 a.m. we are having a classical mechanics session too. Okay, then on 3rd January, then on 8th January. So this is the schedule we are having for special classes, and on the same dates. Okay, if I am going to talk about these live classes which will be on this channel, that is Unacademy Live CSIR UGC net. So on these same dates at 8:30 a.m. in the morning, 8:30, you are having the live class here as well. So before this 10 a.m. class at 8:30 we will be live here, okay, on this channel, and that's how the classes will get conducted, and dates you can check here once. Clear? Now guys, what are the benefits of taking the Unacademy Plus subscription? You will get the well structured and the well planned courses which will help you all in your best preparation for the exam. Weekly quizzes will be there, doubt clearing sessions will be there, mock tests will be there. Okay, when you will take the Unacademy Plus subscription, you will be able to attend all these or you will be able to get all these benefits. Now PDFs of important notes will be available to you, and you will get the guidance of all the top educators, because you will be able to attend the live classes by all the top educators we are having on Unacademy Plus for your exam preparation once when you will take the Unacademy Plus subscription. And guys, whenever you are going to take the subscription, use the referral code, apply it, and get the 10% discount in the total subscription amount. Clear? So this was all about the Unacademy Plus subscription and other important points. Now let's start the discussion about our today's topic, that is the contour integration. Very good morning, Arujyoti. Okay, and guys, when I'm going to do this discussion, and at any point of time, if you will have any doubt, if you want to discuss, like you want me to explain anything else, okay, like something is not clear, you can let me know about it and we will discuss that point. Clear? So that's how we are going to discuss the things. Now I'm going to explain each and everything to you, okay, from the beginning, from the basics, and I will clear each and every point related to the contour integration. Okay, so now let's start from the basics, and let me just provide you a very clear idea, because once you are going to attend this session and in the sequence the other sessions we are having related to contour integration, you will not have any difficulty in solving any question of contour integration later on. So guys, let's start the discussion about it. See, first of all, if I'm going to talk about the contour integration topic, it is, you can say, it's a 5-star topic, okay? And when I'm saying 5-star topic, or it's like a very very important topic, you can even say it in this way, because yeah, it's most expected one, most important, and yeah, you all should know about it very clearly. Along with this thing that yeah, it's important, this is very easy as well, and you all will find it easy. If till now you don't find it easy, it's okay. Okay, so it's going to be easy for you once you are going to attend this session. Very good morning, Aparna. Very good morning, Vishwajit. Yes, Rajeshwari. Rajeshwari, yesterday we didn't have that class. Okay, so most probably today in the evening we can have that class. So yesterday I have scheduled that class, but it has not, like it was not there. So it's okay. Today in the evening maybe we will schedule it, and that will get conducted. Done. Yes, विश्वजीत. ओके विश्वजीत, हिंदी और इंग्लिश दोनों में एक्सप्लेन करेंगे, ठीक है? तो अगर आपको कहीं पर भी डाउट हो, क्योंकि मोस्ट ऑफ द स्टूडेंट्स से, बहुत सारे ऐसे स्टूडेंट्स हैं जो कहते हैं कि इंग्लिश में एक्सप्लेन कीजिए, ठीक है? तो दोनों में मैं कोशिश करूँगी, बट अगर आपको फिर भी कहीं पर कुछ क्लियर नहीं होगा ना, तो आप मुझे बता दीजिएगा. आई विल एक्सप्लेन इन हिंदी वंस मोर. ठीक है, तो मैं फिर आपको वो हिंदी में दोबारा से एक्सप्लेन कर दूंगी. डन. So guys, first of all, see, when you are going to study this topic, you should have a clear idea about this thing, that what kind of questions you can expect. Okay, so initially I will give you the introduction about the topic, that we are studying this topic, why we are studying, what are the things we need to know, what are the steps we need to take to solve this kind of question, and every important point I'm going to consider in these sessions of contour integration. Okay, so guys, first of all, here we are going to have the different types of questions based on the contour integration. तो यहाँ पर जो आपको अलग अलग तरह के क्वेश्चंस मिल सकते हैं ना कंटूर इंटीग्रेशन के, वो कैसे क्वेश्चंस हैं, सबसे पहले उनकी बात करते हैं. और देखिए, ये सब जो हमारे पास जो हम डिस्कशन कर रहे हैं, दिस इज आफ्टर एनालाइजिंग ऑल द इम्पॉर्टेंट क्वेश्चन पेपर्स, नॉट ओनली CSIR नेट, नॉट ओनली गेट, जितने भी आपके इम्पॉर्टेंट क्वेश्चन पेपर्स होते हैं, ठीक है, उनको एनालाइज करने के बाद में वी आर हैविंग दिस क्लियर, दिस इंफॉर्मेशन दैट ओके, this kind of question we can expect, and it's going to include almost everything जो आपको चाहिए. कोई भी क्वेश्चन कंटूर इंटीग्रेशन का सॉल्व करने के लिए you are going to get everything here. Done. So first type of question is integration over C, that is integration over the closed contour C, fz dz, and I will also discuss the questions with you guys once I will complete this discussion. Then we will go to the questions and we are going to discuss the questions so that everything will get clear to everyone. Now, so first kind of question in which they give us the integration over any contour C, okay, fz dz. Now the point is how they can give us the information about this contour. So guys, basically they can give you C such that mod z minus, I can say C1 is equal to R, where this C1 is going to represent the center of that circle. And generally when they give you this kind of equation to let you know about the contour, okay, that's going to have this kind of equation, which is the general equation of circle. Clear? So this value which we will have here, this will represent the center of the circle. Now the point is, okay, अगर यहाँ पर हमारे पास z+2 हुआ, ठीक है, अब यहाँ तो माइनस साइन नहीं है, अब क्या करेंगे, सो इट्स ओके, आपको क्या करना है, आपको बस ना इसको जीरो से इक्वेट करना है. सो व्हेन यू विल इक्वेट दिस विद जीरो, you are going to get the center of the circle. So this is -2 now. So you will get the center just by equating the given expression within the mod or the magnitude with 0. तो देखिए यहाँ पर as I have told you, C1 is the center. Why I am saying this? Because when you will equate z minus C1 with 0, you will get z is equal to C1. क्लियर? सो यहाँ पर C1 ही सेंटर है, बट अगर प्लस भी आ जाता है या कहीं आपको कोई भी डाउट हो, देन यू कैन डू वन थिंग, यू कैन equate the given expression with 0 which is present within the mod, okay, and you will get to know about the center of the circle. Clear? Now next thing is, whatever thing you will get on the other side, that will represent the radius. Clear? And let's say if there is any other constant a or b present here, you have to simplify it, take it in the denominator on the other side, and then got to know about the center of the circle. Clear? And why it's important to know about the center and the radius? It is very important guys, because it's going to let you know about this thing, that when you will find the poles, now when I'm going to talk about the poles, I will let you know that how to find the poles, what is the importance of the poles, what is the role of the pole. Clear? So everything I will explain. So guys, it's going to be the discussion one by one about each and every point. Clear? So this is our first kind of question, and this kind of questions have been asked in the previous years CSIR net physics exam as well as in the gate physics exam. Okay, so it is also one of the very important type of question from the contour integration, in which they give you the contour over which we want to find this integration. Now what are the steps we will take to solve this kind of question? So there are some very basic and the simple steps, like step 1, to solve this integration. Okay, that was the information about this thing. Then if the contour or the circle equation is given to you, what information that equation is providing you, or how you can know about the center, how you can know about the radius. Clear? Now the step 1 to solve any question of this kind. And guys, one more thing, that these steps which I am going to share with you now, so these steps are the very common steps and will help you to solve the different questions of contour integration. तो जो बाकी के और क्वेश्चंस मैं आपके साथ डिस्कस करूँगी ना, टाइप ऑफ क्वेश्चन फ्रॉम द कंटूर इंटीग्रेशन, तो ये जो स्टेप्स हैं ये स्टेप्स बहुत बेसिक है, मतलब कि ये सब जगह अप्लाई होंगे, ठीक है। तो इनको आपने बहुत अच्छे से समझना है, क्योंकि इनकी हेल्प से ही आप बाकी डिफिकल्ट वाले, थोड़े डिफरेंट वाले क्वेश्चंस को भी सॉल्व कर पाएंगे। क्लियर? सो ये स्टेप्स बहुत ज़्यादा इंपॉर्टेंट है। स्टेप 1, अगर हम बात करें कि ओके व्हेन आई वांट टू सॉल्व दिस कंटूर इंटीग्रेशन क्वेश्चन, मुझे क्या स्टेप्स लेना है, तो सबसे पहला स्टेप है यू नीड टू फाइंड द पोल्स। क्लियर? सो फाइंड द पोल्स। नाउ द पॉइंट इज हाउ टू फाइंड द पोल। क्लियर? तो उसको मैं आपको सेपरेटली एक्सप्लेन कर देती हूँ। मान लीजिए आपको जो क्वेश्चन दिया गया है, दैट क्वेश्चन इज z² - 3 अपॉन z + 2 and z square minus 4. Okay, now the point is what are the poles, and this is the question. Clear? अब यहाँ पर ये किसी भी टाइप का इंटीग्रेशन हो चलेगा. Now the point is, but first of all if I am going to consider the pole, तो पोल कैसे आएगा? Let's talk about that. Yes Arupjyoti, somewhere you will find like I can also call, I'm going to find the singular point for this given function. Okay, so singular points are also like, you can say either the poles or the singular points. So both values you are getting, you can call them either pole or singular point, it's okay. Now the point is guys, if I'm going to talk about the poles, to find the poles, or what is the basic meaning of pole, ठीक है, जनरल पोल होता क्या है? कोई भी फाइनाइट वैल्यू z की जो आपको मिल रही है, कैसी वैल्यू? फाइनाइट वैल्यू ऑफ z which is going to make this function infinity. ठीक है, z की वो फाइनाइट वैल्यू जो इस फंक्शन को क्या बना दे? फंक्शन कौन सा? जिसका हम इंटीग्रेशन फाइंड कर रहे हैं, ये फंक्शन जो इस फंक्शन को क्या बना दे? इन्फिनिटी बना दे, वही क्या होता है? पोल. सो बेसिकली पोल इज नथिंग बट दैट फाइनाइट वैल्यू ऑफ z which at which this function is not defined. Clear? At which this function is not defined. Clear? Now अगर मैं आपको कहूँ कि मेरे पास ना कोई भी फंक्शन है जिसका डिनोमिनेटर क्या है? 0 है, न्यूमरेटर कुछ भी है, इट डजेंट मैटर, बट अगर डिनोमिनेटर 0 है तो क्या होगा? इट विल बिकम इन्फिनिटी. क्लियर? सो दैट मीन्स आई वॉन्ट टू नो अबाउट दोज वैल्यूज फर्स्ट, ड्यू टू विच और व्हेन आई एम गोइंग टू कंसिडर दोज वैल्यूज, द वैल्यूज कैन मेक द डिनोमिनेटर 0. सो सबसे पहले तो मुझे वो वैल्यूज का पता करना है, क्योंकि अगर मैंने वो वैल्यू डिनोमिनेटर में पुट कर दी और बाई चांस z की वही वैल्यू हुई तो क्या होगा? फंक्शन बन जाएगा इन्फिनिटी. सो टू नो अबाउट दोज फाइनाइट वैल्यूज ऑफ z, जनरली टू फाइंड द पोल्स we find or we equate the denominator with 0. So whatever value you are having in the denominator, equate it with 0. So you will get z is equal to -2. This is one pole. Okay, and I just need to make a little change here. Just a second guys, let's take 9 in place of 4. Okay, excuse me. Now when I want to know about the other point, that's going to be z² - 9 is equal to 0, and it will give us z is equal to ±3. Clear? +3 and -3. Now the point is we are having different poles existing here. One is -2, another one is +3 and -3. How many poles are existing? 3 poles. Clear? Now next thing is, when we are finding these poles, according to the Cauchy's residue theorem, we are having the statement. I will let you know about that, but how to find the poles, that I have explained to you. Clear? So any finite value of z, it is not necessarily that you will every time get it with the denominator only. No, you may also get it from the numerator. Now what is the example for the numerator case? If I will say I am having any function given here in which in the numerator there is log z present, okay, where there is log z present in the numerator. Do you know log 0 is having the value infinity? So z is equal to 0 is finite value. Let me just show this to you. Log z upon z. Clear? So even if I'm going to say z - 1, done. So z is equal to 1 and z is equal to 0. Both will be the poles. Why? Now from where I have got this z is equal to 0 value? Because log 0, if you will check, you will get that log 0 is infinity. It's not defined. So what I want to explain here to you, that it's not only about the denominator. It is about any finite value of z which can make your function infinite or not defined. So that's the pole. It can be in the numerator as well, but normally or generally in the questions we got to know about the things, okay, or the poles from the denominator part. Clear? So that's how we are having this thing. Clear? So I hope that now the concept of poles clear to everyone, that how you will find the poles, what are the steps you need to take, and everything. Now the second thing, the second step to solve the questions of contour integration is that you need to find the residue at poles which are lying within the given contour. Okay, so that contour, like here it was just a circle. The equation of the circle will provide us this information about this thing, that what kind of circle it is. Okay, and then with these values, let's say we are having the equation of the circle given to us, that is z minus 1 is equal to 1. Clear? So in this case, what is the center of the circle? That's 1, because this value provides us the information about the center. And even if you are having any doubt, do one thing, equate it with 0. Whatever value of z you are getting, that's the center. So z is equal to 1 is the center of the circle. This thing provides us the information about the radius. So radius is 1 unit, center is also at z is equal to 1, which is on the real axis. So if it is imaginary axis of z, this is real part of z, then at z is equal to 1, you will have the center of the circle, okay, and the radius is also 1 unit. So this point will be 2 and this point will be 0, from where the circle will pass like this. It's not looking like a circle, but let's consider it. Done. Z is equal to 1, having the center of the circle, z is equal to 1 was also the radius as per this given equation. Clear? Now the point is, if I'm going to ask you, is there any pole out of these ones, okay, out of these poles, minus 2 plus 3 minus 3, which is existing within this contour? Is there any pole existing? No. So do I need to find the residue? No, I will not find the residue in this case, because I just want to find the residue at the poles which are lying within the given contour. Okay, so if the poles will be related to contour, they will exist within the contour, then only I will try to find the residue. You need to focus on this part, and you have to be careful about this thing, that if the poles are not existing within the contour, you will not find the residue. It's important, guys. And many a times when somebody is just going to learn this topic, like recently you have learned, you are getting to know about the points, so you may miss these little points, but they are very, very, very important. If you will miss them, your answer may get wrong. So focus on these points. Now the step 3. So these steps are common for almost all the questions of contour integration, whatever kind of question you will have. Now the step 3 is, after knowing about the residue, and to find the residue you need to know about the formula to find the residue, which I am going to let you know after this. Okay, so our step 3, that is the last step, is the integration over the closed contour. Cauchy's residue theorem states or tells us about the formula to find the contour integration over the closed contour. Clear? So integration over the closed contour will be equal to 2 pi iota into sum of residue at the poles which are lying within the contour. Clear? There is one more thing. You will use this formula when the direction of the contour is given to you counterclockwise, or you can even say anti-clockwise. Done. And if the direction of the contour will be given to you clockwise, then you need to use the formula that's going to be this one. So I'm including all the important things during the discussion. Once you are going to complete this discussion or these sessions you will complete, your contour integration will be the like I would say the topic in which you will have a very good command. Clear? Huh. Yes, Arupjyoti. Analytic function is a function. First of all, if you want to understand it in the mathematical way, you can say which follows or which satisfy the Cauchy-Riemann equations. Okay. So there we are having the Cauchy-Riemann equations. If any given function satisfy those equations, that is going to be analytic. Or you can even call it which is defined in all space. Okay. So which is not defined at any point. Okay. Which is like defined everywhere. So that's analytic. If I'm going to say any function is not analytic at this point, that means it is not defined. Its value is infinity. Okay, or in terms of mathematical expressions or the formulae, Cauchy-Riemann equations are there. Done. So in the other words, if the function is defined and or it is differentiable and all those properties it's going to satisfy, then it is analytic. Done. Now the next thing is, guys, as I have told you about the second step, that is you need to find the residue at the poles which are lying within the contour. Clear? Now there are different formulae to find the residue. Now guys, when you find the poles, okay, so let's say you are having the fz given to you, which is, again I will take one example and then I'm going to let you know about it. Let's take it. This, okay. Now guys, how many poles you are getting? Can you please let me know if you are getting the poles from here, from this expression? What are the poles? And guys, at any point of time, if you are having any doubt, you want me to discuss it again, like anything is not clear, please let me know about it. 3 poles. Okay, that's very good, Arun. What are the poles which are existing here? Very good, Shriparna. 1 and -2. That's good. See, it's going to be z is equal to 1 from here. If you will equate it with 0, you will get z is equal to 1. Since this is the, I would say the overall power, I think Arun has considered 1 and 1 twice. But that is the same value. Okay, so we'll consider it just 1. Now, from this one, if you will equate this term with 0, you will get z is equal to -2, which is again a pole. So how many poles you are getting? There we are having the 2 different poles. Along with that, guys, there is one more thing corresponding to the poles you need to know. That is order of the pole. So when you are going to observe this term, here is the overall power of this term you can observe. That is 2. Okay, this power tells you about the order. Z is equal to 1 is a pole which is of order 2. So you need to observe this overall power to know about the order. Why it's important? Because when you will find the residue corresponding to the pole, you need to know about the order of that pole, and corresponding to that you will find the residue. Okay, because there are different formulae for different order pole. What is the order of this pole? Observe it. What is the overall power? And just the overall power you need to observe. That's 1. So what is the order? Order of this pole is 1. Clear? Similarly, if it will have overall power 5, you will say that the order is 5. Clear? Now, this is also known as simple pole. Order 1 pole is also known as simple pole. Done? Now, why it's important for us to know about the order of the pole and all these things which we are discussing right now? Because guys, you will have different formulae corresponding to the different order poles. If you are having order 1 pole, clear, then what is the formula you will use? Order 1 pole, which is also known as simple pole. To solve this kind of question, you are having 3 different formulae. Clear? What are these 3 different formulae? Formula number 1, to find the residue. Okay, if you want to find the residue, so then you should know about these formulae, because here residue is an important part of that contour integration. So order 1 or the simple pole, for that if we are going to find the residue, our first formula is residue of the function at z is equal to a. Let's say in general z is equal to a. We have considered the pole which is a simple pole or order 1 pole. When I have considered it, z is equal to a. This is the value I've got, which is a simple pole. Okay. Now the formula is limit z tends to a, z minus a and fz. So it is very simple, guys. You just need to revise it, and once you will revise it for some time, and that's going to get clear. Or when you will use them in the questions, then also you will have good command on the formulae. Clear? So it's simple. It is so easy. Now the second formula is same for the simple pole or order 1 pole. If the function which is given to you in this form, that should be in fraction, numerator should be there, denominator should be there. This is the given function for which you want to find the integration. Okay, so that function I'm writing here, that's going to be integration over c fz dz. So this is the function. It should be in this form first of all. Clear? If it is in this form, you can think about the second formula to find the residue. Now the point is, when it is in this form, after this, what is going to be our next step to find the residue of this function at any simple pole? So guys, you need to check few conditions. If these conditions will get satisfied, then only you will use this formula, second formula, okay, to find the residue. So that is, conditions are that the value of the denominator at the pole should be equal to 0, and that will be equal to 0 because generally when we find the poles, okay, we equate the denominator itself with 0 and we get that value of z at which the function will be 0, or the denominator part of the function will be 0, and the total function will be infinity. Clear? So the denominator is 0, but the numerator at the value of the pole should not be equal to 0. So if these conditions will get satisfied both, then you can use the second formula. Now what is the second formula? Formula is residue of the function at z is equal to a, this is for the simple pole, will be equal to psi z, this is psi z, upon phi dash z, and the value of the z you need to replace with a. Clear? At the end, where denominator, in the denominator I have considered the first order derivative of the denominator, and that's how we are getting it in this manner. Okay, now guys, this is something which we are having, and that's how you can just use it and get the residue of the function at any given simple pole. But the conditions I'm telling you, the condition should get satisfied, then only you can use second one. Corresponding to the first, there is no condition. You can use it whenever there is simple pole, but guys, still there is no condition. But when we do the selection of the formula, we try to find it in this way, that okay, will it be easy for me to use it and to do the calculation to get the answer or not? So that's what you need to check. Okay, and then be careful whenever you are doing the selection of the formula for solving any question. There is one more formula, third one, which is applicable not only for the simple pole, that is also applicable for the order n pole. Okay, so this third formula is applicable for simple pole or even, okay, and for order n pole. Now what I mean by order n, when I am saying order n is greater than 1. Clear? So simple pole means n is equal to 1, okay, or order 1 pole, so that is known as simple pole. But when I am saying order n, that means n can be greater than 1. Now the thing is, if I want to find the residue of the function at that pole, let's say the pole is z is equal to a, the pole is existing at that point, this point. Clear? Then steps will be there to find the residue corresponding to these poles. Steps are, consider z minus a. You just need to take it on the other side. That is pole. Z minus a is equal to t. Consider it equal to t. Okay. Once we have considered it equal to t, then in that case, this is what? This is the pole. Done. Z minus a is equal to t. After this, wherever you will have z minus a present in the given function, replace it with t. So basically what you need to do, wherever in the given function z minus a is present, replace it with t, and wherever only z is present, let's say a is not along with z, so z minus a is not completely present there, but only z is there, then wherever only z is present in the given function, replace it with, what we will do, in place of z we can write t plus a. So basically we are trying to remove z from everywhere. Okay, so what we are doing, we are removing or replacing z with t. Shriparna, yeah, corresponding to each formula I will discuss the question. Okay, so each and every formula which I have discussed with you, the condition, situation and everything, that's why I have planned more sessions for this topic, because it's not possible to discuss everything in one session, so there are more sessions. Okay, and guys, one more thing, most probably if it will get scheduled today in the evening at 8 o'clock, you may have the other session of this topic. Okay, at in the evening at 8 o'clock, so you can even check at that time. Okay, so otherwise tomorrow in the morning 8:30 a.m. you are having the session, that's confirmed, but in the evening also, because yesterday's session that may be there in the evening, and since that was the part 1, okay, it has not been there, so that's why this we will consider as the part 1, and the other session is going to be our second session, so don't worry. Done. So guys, it's going to be replacing z with t. Okay, now the point is, basically it's so simple and easy, don't get confused anywhere. First of all, consider z minus a as t, where a is the pole, and wherever z minus a is present, replace it with t. Wherever only z is present, not z minus a, replace it with t plus a. After this, what do you need to do? Find the coefficient just a second guys. Okay, let's do the discussion on this remaining portion of the page. So yeah, we were talking about this thing that after this you just need to consider the coefficient of 1 upon t. Okay, so till that point we have discussed that how we are going to remove z from everywhere. Clear? After that, what we will do, we just need to consider the coefficient of 1 upon t. That will give you the value of the residue of the function at z is equal to a. Clear? So that's how you can easily get the residue of the function at z is equal to a pole. It can be a simple pole or it can also be order n pole. Done? So this formula is applicable for both the situations. Now the thing is, if I'm going to talk about the other formula or the expression corresponding to the order n pole, so what is that formula? Let's talk about it. See, so coefficient of 1 upon t, when we will find, that's the residue of the function at z is equal to a pole. The next thing is, what is the next formula to find, I would say, the residue of the function at the order n pole. Clear? So there is one more method, that's the last one, and after that we are just going to talk about the contour integration questions. Now the thing is, you can see when we are talking about the method or the steps to find the residue, that will be applicable here. Okay, the order, poles and everything we have discussed, that how to know about the order, how to know about the pole. Now the point is, what is that formula which is going to help us to get to know about the residue of order n pole. Clear? So let me just tell you about it. See, if I'm going to talk about this thing, that order n pole is there, okay, and you want to find the residue corresponding to this pole. Okay, thank you very much, Shashank, and same to you. So corresponding to order n pole, here we are going to have the formula, which is 1 upon factorial n minus 1, okay, dn minus 1, dzn minus 1, z minus a to the power n, and fz. Fz is that function for which you want to find the integration, you are finding the poles from which function, so that same function we are considering here. Clear? So that's how, guys, you can easily find the residue at z is equal to a pole, which is the order n pole, and n is greater than 1. It can be 2, it can be 3, it can be 4, it can be 5, or it can be like any other value as well. So that's going to be dn minus 1 upon dzn minus 1, z minus a to the power n, fz, and its value at z is equal to a at the end you just need to put. Clear? So this is how you just need to know about these formulae. I hope, guys, most of you, those who are going to study this topic today, are new to this topic and you have not studied it earlier, or when you have studied that was like for your masters or your semester exam. Okay, so what do you need to do? The things which I'm discussing with you, you can do one thing, that you can make a formula notebook along with this discussion which I'm doing, okay, during these sessions. So when you will note down all these important things in your formula notebook, that will help you to do the quick revision, that will help you to prepare the topics very well, because you can do the revision at any point of time. So I would suggest you one thing, during your preparation you can do, like you can prepare or make two notebooks. One is your practice notebook, in which you will solve the questions, you will practice the questions and make them subject wise. Not many notebooks, no, just one single notebook, that is formula notebook, another notebook, that is practice notebook. But in those two notebooks, make the partitions like first 25 to 30 pages, or for the practice notebook I think you will need more pages, but for the formula notebook, first 25 to 30 pages for mathematical physics, then next 25 to 30 pages for quantum, classical, then solid state physics. Like in this way, just allot some number of pages for a particular subject, and in this way what will happen, you will have every important formula in your formula notebook, with the help of which you can do your regular revision, okay, which will help you to get familiar with all these type of questions and all these important points. So guys, do it in this manner, because formula, like all these formula are going to play a very important role in your preparation. Clear? So if you can do it in this manner, try to do it in this way, and that will be helpful for you. Clear? Now the point is, this was the discussion about the residue, and after knowing about all these formula, you can easily solve any question of this kind. So now let's discuss some of the questions of residue, or the contour integration completely. Okay, so let me just show you some questions now. See guys, here is the statement of the Cauchy's residue theorem. That's going to be, if fz is single valued and analytic in a simple closed curve, C, except at a finite number of singular points within C, then integration over the closed contour C, fz dz is equal to 2 pi iota into sum of residue at the poles which are lying within the contour. Now the point is here, since we are talking about the closed curve or the closed contour. Clear? Along with this, if I'm going to consider, or I'm going to talk about the open contour, because based on the open contour also we already had the questions in the previous years, then how we will solve the questions based on open contour. I will discuss that thing with you guys, okay, and those questions also I will include in the session, so don't worry about that. Now here is our first question from the GATE 2018 exam, and you all can observe the steps once, and then I will also start the discussion about all these steps, okay. And I think, yeah, this is 3z square. After this there is just dz, there is nothing else, it's just dz, okay, so don't worry about it, nothing is missing, it's dz here only. Clear? So guys, just try it once and let me know which option is correct according to you, if you will get the answer. And if there will be any doubt or difficulty, don't worry, I will discuss each and every step with all of you. Clear? So now our questions will start. This question is from the GATE 2018. We will consider the questions for GATE and NET, both the exams. Mainly each and every discussion which we will do will be for CSIR NET physics exam and relevant to the exam. Whether the questions are from GATE exam, it's okay, but they are also important for the NET exam, okay. Once you are going to get the correct answer, please let me know which option is correct according to you, and in just some time I'm going to start the discussion. Excuse me. Or guys, even if you are having any doubt that okay, this is given, how I can proceed, how I can take my first step to solve it, any kind of query or the question if you are having, just mention it, I will discuss that point. So you are free to ask your doubts related to the questions, okay, at any point of time. And guys, solve it like, even if you need to do the calculation, do it, because in the exam you have to do that. Clear? So that's important, that yeah, you should work on the steps, you should do the calculation on your own. And there are few things I have mentioned here on this slide. Even if you will not mention those things, you will be able to reach to the correct answer quickly. So I will discuss that. Guys, once you will get the correct answer, please let me know which option is correct according to you. Okay, can I start the discussion now? Let me know if I can start the discussion, and let's do it together then. Okay, let's talk about it, guys. Now, the question is the absolute value of the integration which is given to us, which is 5z cube plus 3z squared upon z square minus 4 dz. Okay, over the circle, this is the equation of the circle given to us, and this question has been asked in GATE 2018 exam. Clear? So, over the circle, this. Now, what this equation of the circle is telling us, is providing us the information that the center of the circle is 1.5. Z minus 1.5 is equal to 0, and I will get the value of z, that is 1.5. So that is the center of the circle. Clear? And this 1 unit is the radius of the circle. In complex plane is dash. Up to 2 decimal places we need to write the answer. It is NAT type question in the GATE exam. Clear? So, the options which are given to us are these options. I would suggest you one thing, don't go for these steps directly, just what I have already written. Let's do it right now at this moment. Clear? See, our first step, when I have told you about the steps you need to take to solve any question based on the contour integration, steps were: step 1, find the poles. Step 2, find the residue. Formula I have discussed with you. Step 3, use the Cauchy's residue theorem, and the integration over the closed contour will be equal to, done. These are the 3 steps. What is our first step? Poles. What are going to be the poles? Z is equal to plus minus 2, because z square minus 4, when I will equate with 0, I will get z is equal to plus minus 2. Clear? Next, step 2. What is the order of this pole? Overall power is 1. So order of the pole is 1. Now, I can use any of the methods to find the residues here. Okay, because even if I will consider the first method, second or third, I can use any of them. But the thing is, which one will be more convenient, more easy? We just need to consider that. So I think that the first method of finding the residue for the simple pole is going to be very easy here. So I'm going to use that. that is, but one more thing guys, we need to check that we are getting two poles here. Okay, are these two poles lying within the contour or not? Contour is a circle, okay, which is having the center at 1.5, that's on the real axis. So 1.5 is somewhere here, let's say. Clear? And 1 unit is the radius, so that's going to be a circle of this kind. Clear? And 1 unit is the radius, that means this value will be 2.5 and this value will be 0.5 on the real axis. So we are getting two poles, plus 2 and minus 2. Plus 2 will be somewhere here and minus 2 will be somewhere here. Minus 2 is outside the contour. I don't need to consider it. I will just consider the pole plus 2. I will just find the residue at this pole plus 2. So the formula to find the residue at the simple pole, because the overall power was 1, so pole is a simple pole. The formula is limit z tends to pole, that is 2, z minus 2, okay, z minus a, fz. Fz is what? This function. The function is 5z cube plus 3z square upon z square minus 4. Can I write it in this way? Z plus 2 into z minus 2. Clear? So z minus 2 and z minus 2 will get cancelled out, and mostly it happens in the same manner that it will get cancelled out. Then just put the limit. What is the limit? Limit is z tends to 2. When you will put the limit here, you will get 2 to the 4 to the 8, 8 5 the 40 plus 2 to the 4, 4 3 the 12 upon 2 plus 2, that's 4 in the denominator. You are getting 52 upon 4, you are getting 13. Clear? So you are getting 13 from here. Now the point is, this is what? This is the residue. We know that to find the integration finally, what is our last step? That is, integration is equal to 2 pi iota into sum of residue. Only one residue we have got, that is 13. So our answer is, let me just show you the next slide. See, 13, that is the residue. Clear? And then last step, use the Cauchy's residue theorem, that is 2 pi iota into sum of residue, that is 13 only we have got as the residue for this given question. 13 into 2 pi iota, 26 pi iota, and that's going to have the value 26 into 3.14 into iota. When you will multiply it, you are getting 81.64 iota. Okay, so you just need to write it 81.64 till 2 decimal places. So you just need to mention the numerical value here, so which is option A. Clear? That's how you can solve any question of this kind. I've shown you like each and every step, and it is like very easy. If you are still having any doubt, don't worry, just observe the things, okay, and try to solve such kind of questions. Okay guys, there are more questions which we will consider in our next session of contour integration. There is going to be more session. Okay, so this was our first session of contour integration. There will be more sessions, so there I'm going to consider more questions of different type based on different formulae and different situations, even the very different questions, then very different in the sense the type of questions you can expect in the exam. Yes Arun, yeah, very good morning Vivek. Arun, the figure is like, see, this was the equation of the contour given to you, that is z minus 1.5 is equal to 1. So do you know about this thing that 1.5 is telling you about the center? Like here I have explained about, just a second. See, this equation of the circle, let me just show you that. See, when I've talked about this type of question, I've told you z minus c1, this is the center. Or even if you are having any doubt, do one thing, equate the mod value with 0. Whatever value is present within the mod with 0, you will get the value of z, which is the center of the circle. Clear? After knowing about the center of the circle, you can also get the radius, whatever exact value you are having on the other side. Okay, that's the radius. So the equation which you are having right now, let me just show you that. Just a second, let's go back to that question. See, here the value which we are having is z minus 1.5 is equal to 1. Center is 1.5 units. Okay, so you can see at 1.5 I have taken the center of the circle. Then radius is 1 unit, so you can see I've just drawn the 1 unit radius circle which is having the center at 1.5. Then there were two poles. I've got plus 2 and minus 2. Only plus 2 was existing within this contour, minus 2 was not existing within the contour. I just need to consider the pole which are existing within the contour, okay, and that's why I have just considered plus 2. Done. So that's how you are going to draw this figure, and you don't need to go with all these things which I have written extra here. So directly you can just get it done. I hope guys each and everything which I have discussed in this session will be clear to everyone. Guys, there is another session as well of contour integration. Okay, as I have informed you about it, there are chances that today at 8 p.m. you may have the other session. Clear? So you can even check it once. Otherwise, like if at 8 p.m. today we may have, so the other session which will be tomorrow in the morning at 8:30, that is fixed. Okay, but today's evening session you can check once it will get scheduled here. Done. But tomorrow's session is fixed, that will be at 8:30 a.m. in the morning. And guys, as I have told you about the Unacademy Plus subscription in the beginning and about our special classes schedule as well. So these are the special classes and the dates and the timings I have mentioned here. So you can see, so for classical mechanics, special classes are going on today on 2nd January as well. At 10 a.m. we are having our special class on Unacademy Plus. Okay, for which if you want to do the registration, you can do it from the Unacademy Learning app. Okay, in the special classes category, so you will be able to do this registration. Registration is free, and if you want to attend the sessions, you can. So this is the schedule. These classes have already been launched. Okay, already been scheduled, so you can attend them. And yeah, these are the fixed timings, fixed dates. Also guys, on these same dates you are having the YouTube live sessions here on this channel, that is AnjaliALive CSIR UGC net. So you can even attend the live sessions here on these same dates. Okay, if there will be any changes, I will inform you about it. And the live classes here we are having at 8:30 a.m. and these special classes are at 10 a.m. Done. These are the new plus courses guys, which are just going to start in January. Okay, recently these courses are going to start in Unacademy Plus. Okay, also guys, you can attend all these courses and their live classes by taking the Unacademy Plus subscription. Also the other information I have mentioned here, so if you want to attend the live classes of all these courses, you can take the Unacademy Plus subscription. Clear? And you can attend the live classes by all the top educators which for the courses which are going on Unacademy Plus for your exam preparation. Done. All these courses will be important for you and for your preparation. They will help you to prepare well, to know about important things and every important point. Steps to take the subscription are: step 1, download the Unacademy Learning app. Step 2, in the Unacademy Learning app, select the goal after login to the app. Like if you are preparing for CSIR net exam, select the goal CSIR UGC net. Step 3, just click on the 3 lines you will get at the left hand side top corner. When you will click on these 3 lines, then you will get plus written there. Click on plus, then click on get subscription written there, and you will just get further steps. Follow the further steps. You will get a place to write the referral code, so you can use the referral code, that is Anjali Arora. Okay, by using this referral code, by applying it, you can get the 10% discount in the total subscription amount. So that I have also mentioned here. Done. So use this referral code, apply it, and get the 10% discount in the total subscription amount. Also guys, these are the benefits of taking the Unacademy Plus subscription. Mock test will also be there. PDF of important notes will also be there. Okay, and once you will take the subscription, you will attend the live classes by all the top educators we are having on Unacademy Plus for your exam preparation. And guys, thank you very much for joining this session. I hope that the session was helpful for you. And thank you very much, Shashank. So guys, thank you very much for joining this session. Today in the evening, either we will have one session of contour integration at 8 p.m. okay, today in the evening, or Tomorrow there is like a fixed timing, that is 8:30 a.m. Tomorrow's session will surely be there. Done. So thank you very much everyone for joining this session. Thank you.